So we went over this yesterday. So let's see how much we remember. What form is this currently in? Exponential form. Excellent. What form do we want to be able to put it in? Logarithmic. Okay, so what goes where in logarithmic form? What do I write first? Log. The base 2. Why do I write base 2? The 2 is right there, so it goes as the base of the log, but it's also the base of the exponent, right? Then what? Of 32. What's it called right here? Remember the argument? And over here it's the answer, right? They both start with an A. We're good with that? Equals what? 5. And why does equal 5? Because that's the exponent. That's what we're trying to get out of the exponent and into a place where we can solve it. Or figure it out or whatever, right? Now, nothing to figure out here, is there? Because we know everything. We know that this is a true statement right now, right? 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. We know that's a true statement. We're just figuring out how to go back and forth between these two things, right? Okay, so can you go back the other way? If I say log base 7 of 6 equals x, can we do that? Okay, what do I write? Why do I write 7 first? So 7 is the base of the log, so it's also the base of the exponent. To the x power equals 6. Okay? We got that? We're comfortable with that. All right, then let's go through a couple problems just to make sure, just so that we're positive. 6 squared equals 36. Someone who has not spoken. Try this one. Log. Can you try one more time? Log base 6, excellent. Of 36 equals 2. Is that correct or incorrect? Correct. Excellent. Okay, try this one. 16 to the negative 1 power equals 1 over 16. Somebody who hasn't tried one of these yet. Log base 16. Good. 1 over 16 equals negative 1. Right or wrong? Good job. Okay. Let's try one more. 125 to the 2/3 power equals 25. Somebody who hasn't spoken. Log base 125 of 25 equals 2/3. You have any questions about that? You're okay about this? Okay, so then here is where we're going. Okay? What if I say to you, log base 3 of 81? That's all I tell you. Log base 3 of 81. And my directions to you are evaluate. Now my directions are not solve because it doesn't equal anything. There's no x anywhere, right? I'm not trying to solve anything. But evaluate means I want to know what this is the same as. So it's kind of like solving, but there's no variable to solve for. You okay with that? How do you think we might go about doing this? Could we pretend that it equals something? We could, right? What do you want to pretend that it equals? Well, we can't give it a value like a 0 or 1 because I don't know what it is, right? So we could give it an X or a Y. We could even give it a question mark. We could give it a heart. It just equals something that we don't know, like a Z. Okay? What do you think we would do from here? What do you think we might do from here? Oh, you want to put it in exponential form? Okay, so what would this look like in exponential form? 3 to the question mark equals 81. Do you know what the question mark is then? 3 to what power equals 81? That's a good guess. 3 to the 4th power equals 81. So the question mark equals 4. So log base 3 of 81 equals 4. What if I told you log base 3 of 3? What would that equal? Excuse me, directions, evaluate. Well, we could pretend that it equals a question mark. So we could say 3 to the power of the question mark equals 3. What would that question mark need to be? So log base 3 of 3 equals 1. Now, are you ready to be slightly annoyed at me? Okay. I'm used to it, so it's not going to be like, it's not going to bug me very much. Okay? I'm used to when you guys are annoyed at me. I'm a math teacher, so it's okay. Look at this. Log. I'm going back to this problem that we just did. Log base 3 of 81. Enter. 4. I'm going back to this problem that we just did. Log base 3 of 3. Enter. 1. So why would I make you do the hard work of thinking about it in exponential form instead of just putting it in the calculator? In case your calculator breaks, in case you don't have one of these calculators at home, is it still possible to do these problems? Okay, then let's do one more, and you can do it either way. Log base 5 of 1 over 625. Evaluate that. If you get an answer, please don't shout it out, because I want us to think about this. Because if you have a calculator, you're just mashing buttons and hitting enter and writing down an answer. I need us to make sure we understand why that's the answer. Okay? So I'm going to come over here and I'm going to say 5 to our pretend question mark equals 1 over 625. Do you know what power 5 to what power equals just 625? 4, right? 5 to the 4th power equals 625. How in the world would I make that go to the denominator of the fraction? Negative 4. Do you remember that when we talked about negative exponents? Anybody? And if you didn't, you could pull out your handy dandy exponent foldable and remember we talked about negative exponents. A to some negative power equals 1 over a to that positive power. You remember that? So, how many of you just punched this into your calculator? Is that acceptable? Yeah, I told you you could. I even showed you how to do it, right? Okay? But if we don't have a calculator and if we actually have to think about it, I want you to have some knowledge about how to think about it. You okay with that? Negative 4. So, let's try this one. I would like you to try this one without your calculator, please. Okay? You can use your calculator to check after you already have an answer written down for me, but try it without your calculator first. Log base 7 of 49. And again, don't shout it out. Anybody got an answer? Okay, all together, what'd you get? 2. 7 to what power equals 49? 2. 7 squared, right? With or without your calculator, what'd you do? Excellent. Log base, oh, I wrote it on the wrong side. What am I doing? Log base 1/2 of 1 equals what? Evaluate it. Why? Why is that the answer? Anybody? Uh-huh. Say it. Anything to the 0 power is 1. So that's why this is a 0. Good job. Did you hear how I corrected your vocabulary a little bit? Do you understand why mine was right and yours was not quite right? Okay, good. Everybody else? Anybody else have any questions about that? Because what he said was anything multiplied by the exponent of 0. Are we multiplying by exponents? No. We're raising something to a power. Does that make sense? Okay. All right, try this one. Log base 8 of 1 over 512. Evaluate that. What'd you get? What'd you get? -3. Perfect. Because 8 to the negative third power is 1 over 512. 8 to the third power is 512, so 8 to the negative third power would be 1 over 512. Got it? All right, one more. Try one more for me. Log base. Oh, let's do this one. This one's even more fun. Log of 1,000th. Who remembers what I need you to remember? One person does. Who else does? 2 people? Okay, one of you two remind us what we're missing. The base, right? It doesn't look like there's a base, but that's the common log. So what's that base? 10. So what'd you get? -3. Log, what am I doing? 10 to the -3 is 1,000th. Questions? Now, for some of these, there might be like, well, I don't want to say trick, because you guys know I don't like tricks, right? It might be a little shortcut. How about that? Okay? Let me remind you of one that we did just a second ago. It was this, log base 3 of 3. And we were trying to evaluate that. And we said that the answer was 1. Well, guess what log base 4 of 4 is? 1. Guess what log base 7 of 7 is? Why? The base to some power equals the argument. The base to some power equals the argument. The base to some power equals the argument. So if the base and the argument are the same, what's true? It's to the 1 power because what's the exponent here? 1, right? Now, I didn't want you to think that it's always 1, and that's why I brought up the exponent, because think about this. What if it was log base 8 of 8 squared? What if I rewrote that over here? 8 to some power that I don't know equals the argument, which is 8 squared. What is the thing I don't know? Don't the exponents have to be the same? What's this exponent? 2. Doesn't this have to be a 2? What about if it was log, what is that? Log base 9 of 9 to the 4th power. What's that going to be? It would just be 4, right? Because if I rewrote it in exponential form, it would be 9 to some power I don't know equals the argument, which is 9 to the 4th. The some power I don't know is a 4. Does that make sense? Okay, then try this one by yourself. What do you think? It equals 5, right? Equals 5 because what's this base? 10. 10 to the something I don't know has to equal the argument, which is 10 to the 5th. What is the thing I don't know? 5. So if the base and the argument are the same, what's the answer? The exponent, right? If the base and the argument are the same, the answer is the exponent. If the base and the argument are the same, the answer is the exponent. Does that make sense to you? And here's the mathematical reason why. All our work over here was showing our mathematical reason why. But if you don't remember that shortcut, guess what? It's fine, because all you have to do is write it in an exponential form and you'll see what the answer is, right? It's just a little shortcut to save you a little bit of work. Do you want another one of those? Another shortcut to save you a little bit of work? No? No, you don't? Oh, okay. Yes, you do? Okay. Then let's look at this. What if it's the other way? What if it's in exponential form already? And it looks like that. So that's in exponential form, right? But there's a logarithm in exponential form? Ew. That's okay though, right? So if this equals something I don't know, it's in exponential form. What form do I want it in? Logarithmic form, okay? Now, to keep this from being confusing, I'm going to color code it. Those of you who need the color code, it is going to be good for you. Those of you who don't need the color code, it's going to be fine. You just kind of go with me for a second, okay? So I'm going to rewrite this problem like this. I'm going to make the base 7, I'm going to make that green. I'm going to make the base of the log up here just that blue, the same blue color. And I'm going to make the x a red. And then it's going to equal this dark purple, this question mark. Okay? I just need to make sure everybody's with me here. Are you with me? Okay, so here's what we're going to do. This is an exponential form. I want it in logarithmic form. What do I write first? Okay, log base 7 because of that base, right? Let me make that green then. That's green. Log base 7 of what? Question mark. Equals what? This thing up here, right? Log base 7 of x. Well, for these two things to really be equal, what does the question mark have to equal? It has to be x, right? So this equals x. Let me show you another one, so you stay with me. And I'll write it in 3 raised to the log base 3 of 5x equals what? How do I write it in logarithmic form? Log base 3 of question mark equals what? Log base 3 of 5x. That's from the exponent, right? What does the question mark have to equal? 5x. Do you see the trick yet? Oh, not trick. Shortcut. Do you need the shortcut? What's the shortcut? What has to be the same? Look, this is not what I have. This is what I'm given. I want to make it so that if I give you a question like this, 4 log base 4 of 3x, all I have to write down is what it equals. I can write this down if I want, but I want to make it where I don't have to. Okay? Remember shortcuts? Cut down on some work. So, what do you notice? So these bases are the same. The base of the exponent and the base of the logarithm. The base of the exponent and the base of the logarithm. When those are the same, what's the answer? When these are the same, what's the answer? Whatever's left, right? We kind of ignore the log, we ignore the 2 bases. Whatever's left, that's what the answer is. So look at this problem right here and tell me what the answer is. 3x. Because that base and that base are the same. Okay, can I give you a trick one? Okay. 10 log of 15. Why? Oh, it's the common log, so it's a base of 10, so the base and the base are the same, right? So the answer is 15. Okay, can I give you another trick one? Okay. E natural log of 4. We talked real quick yesterday about natural log. Do you remember what natural log is? Oh, it's log base E? We just don't write it like that. We write it like this. So are the bases the same? This base is E. This base is E. What's the answer? 4. Ooh, I'll give you a really, really tricky one. Well, I mean, I can't really give you any more tricky ones than that. That's pretty much all. What about this? This is kind of tricky. It's different, isn't it? This one up here, the log was in the exponent. This one, the log is out front. Are the bases the same? Yes. What's the base of this? E. What's the base of this? E. So what's the answer? X plus 1. That really kind of goes back to this one over here, doesn't it? When the base and the base are the same, the answer is the exponent. When the base and the base are the same, the answer is the exponent. But it follows the same kind of logic. When the base are the same, the answer is what's left. Okay? Questions?